Guys, and welcome back to my channel of Kleptronic. This is a follow-up video of my first video about the Joule Thief charger. I will make a first series videos on that subject because I think it's a fascinating little circuit, especially if you're like me, a debutante in electronics. Well, I'm not a total debutante, but I think you have to have a little experience to be able to use that circuit without blowing things up. But there you go. So I wanted to show you now the setup. So compared to last time, we have this battery here, which was a lithium ion battery, which is totally almost dead, had 1 volt in it. Now, as you can see, I've solely charged it only on those AA batteries. So I'm talking about flat batteries that have less than 1.5 volts. But then again, sometimes you can test them, they have 1.4, 1.5, but then as soon as you load them, the voltage goes down. So it means they're practically flat, and you can't use them in most applications because once the voltage drops too low, the electronics device won't use. So you can extract the last juice with a Joule Thief circuit, and this is what we have here. I will show a little zoom in on the circuit, but what I will do is also at the end of the video, which I'm trying not to go for too long, I will shoot a footage of this circuit so you can see what kind of circuit I've used. And now for the explanation of the circuit again, just to show you. So here you have the voltage of the battery, which is sitting at the moment at 1 volt. Here is the tip 4056, which is charging which is the lithium ion charger. Here's the voltage of the charging voltage. So at the moment it's 4.75 volts, which is good because the tip will take 3 volts and 3.5 volts, but ultimately you want to charge your lithium battery to 4.2, so you want at least a few couple of 100 millivolts above the 4.2. So you ideally would want to 4.5 or something. That means, of course, that you can't push a lot of amps in it, but since there's not a lot of energy in that battery left, you can't push a lot, so you have to be realistic about how much. And so to charge a battery like that, it will take ages, but you can maybe extract, you can maybe charge a whole battery with 10 of these AAs. I don't know, I haven't tested. I'm going to try to do that. I have another one like this, which is 1 point, and one thing I'll probably do another video on time lapse and see how long it will take to charge it and how many batteries I will have to use. I hope I have enough dead batteries. Otherwise, I'm counting on my son to play with his toys and to provide me with some fresh flat batteries. Now, as you can see, the charging voltage at the amperage is about 2.5 milliamp, which is very, very little. So there is not a lot of risk that you blow up this battery. We can't really harm it. The things that I have done is I've blown up a tip 4056 because I did use, like I said last time, I used too big of a capacitor in the output, and I'll explain later why you want an output capacitor there. And here you got the voltage of the lithium battery, which is 3.34, which is still under nominal voltage. Now, the interesting thing to know is once we have charged this fully up to 4.2, and tested it and see, the capacity, and maybe do a discharge to see if the battery is still, has still some life in it. That'd be interesting, but that'd probably be for another video. Anyway, so let's do a little zoom in on my circuit board. There you go. I'll try to go as close as I can with the camera. There you go. Now, as you can see, here you have the switch. Here you have the coil. Now, the positive side is of the battery of the AA cell is connected to the center tap of the coil. These are two linked together. One of the coil endings here goes into a resistor, a variable resistor. I think it's a 20K I'm using, and that allows me to adjust for the voltage, which is good. So to avoid to have too much of a high voltage coming in, and it will do that because normally on the circuit you just put a resistor, but it will do that by regulating the amount of current going into the transistor. Out of the transistor, so the other tap goes into the collector of the transistor. The tap that goes from the variable resistor goes into the base of the resistor, and then you've got the emitter of the base of the transistor, and in the emitter you have is connected directly to ground. Now you have at the end of the collector you have a diode. It's to avoid some back EMF flowing some of the so that the battery of the lithium battery doesn't flow back. You don't have a flow back in a sudden burst of current going through the coil and potentially burning your circuit. And then you've got two capacitors which are in parallel. I mean, they're in parallel here with the transistor collector emitter, and then also at the output after the diode. And that way, because it's an oscillating circuit, it will smoothen the oscillation to have a more steady DC voltage coming out. And there you got it coming out. And this is, again, I'm not going to explain you the circuit. Maybe one day I will. But basically, this circuit uses it's called a blocking oscillator, and it's just using the properties of an expanding and a collapsing EMF field, electromagnetic field generated by the current going inside the coil. So you have the transistor opening and closing very quickly, and that creates a sort of a boost circuit, which is basically what a boost circuit does, which is opening and closing quickly through a coil, and coil resist current change, so therefore it will create a higher voltage spike very quick. I think these circuits go in terms of thousands of hertz, kilohertz, and they oscillate pretty quickly, which enables us to have a more steady DC circuit. And here you go. You can see you got 4.7, still got 4.7 volts, and you can't see it here, but you still have about 1 volt in the battery. So in my experience, once the battery reaches, the AA cell, which is about below, I would say below 900 millivolts loaded, then nothing's going to happen. You can always boost it a bit, but you can continue charging until you get to about 4.3 or 4.4 volts, but beyond that I don't think it's worth doing it. But you can still use the AA battery in a small application. What usually a lot of people use it, a Joule T4, which is lighting up a diode to create it, to use it for a torch, for example, and that'll be a very quick little setup that we'll see for another video. So you can still use some of the energy in those cells, which are already very, very flat, till the end, and use them, for example, if you use a variable light emitting LDR, a light diode resistor. You can use them as a little, light with a transistor circuit. You can use them as a little night light, for example, for your kids when they go to bed. So there you go. Watch out at the end of the video for a footage of the circuit so you can have a look at it. Thank you, and see you at the next video.